If you were born after computers and paper, it doesn't really matter which order you taught with them in. You just want to have the best tool. So another one that comes up is computers dumb math down. That somehow, if you use a computer, it's all mindless button pushing. But if you do it by hand, it's all intellectual. This one kind of annoys me, I must say. You know, do we really believe that the math that most people are actually doing in school practically today is more than applying procedures to problems they don't really understand for reasons they don't get? I don't think so. And what's worse, what they're learning there isn't even practically useful anymore. It might have been 50 years ago, but it isn't anymore. When they're out of education, they do it on a computer. So just to be clear, I think computers can really help with this problem, actually make it more conceptual. Now, of course, like any great tool, they can be used completely mindlessly, like turning everything into a multimedia show. Like the example I was shown of solving an equation by hand, where the computer was the teacher, show the student how to manipulate and solve it by hand. This is just nuts. Why are we using computers to show a student how to solve a problem by hand that the computer should be doing anyway? All backwards. Let me show you that you can also make problems harder to calculate. See, normally in school, you do things like solve quadratic equations. But you see, when you're using a computer, you can just substitute. You can make it a quartic equation, make it kind of harder, calculating-wise. Same principles applied, calculations harder. And problems in the real world look knotty and horrible like this. They've got hair all over them. They're not just simple, dumbed-down things that we see in school math. And think of the outside world. Do we really believe that engineering and biology and all these other things that have so benefited from computers and maths have somehow conceptually got reduced by using computers? I don't think so. Quite the opposite. So the problem we've really got in math education is not that computers might dumb it down, but that we have dumbed-down problems right now. Well, another issue people bring up is somehow that hand calculating procedures teach understanding. So if you go through lots of examples, you can understand how the basics of the system work better. I think there is one thing that I think very valid here, which is that I think understanding procedures and processes is important. But there's a fantastic way to do that in the modern world. It's called programming. Programming is how most procedures and processes get written down these days. And it's also a great way to engage students much more and to check they really understand. If you really want to check you understand math, then write a program to do it. So programming is the way I think we should be doing that. So to be clear, what I really am suggesting here is we have a unique opportunity to make math both more practical and more conceptual simultaneously. I can't think of any other subject where that's recently been possible. It's usually some kind of choice between the vocational and the intellectual. But I think we can do both at the same time here. And we open up so many more possibilities. You can do so many more problems. What I really think we gain from this is students getting intuition and experience in far greater quantities than they've ever got before. An experience of harder problems, being able to play with the math, interact with it, feel it. We want people who can feel the math instinctively. That's what computers allow us to do. Another thing it allows us to do is reorder the curriculum. Traditionally, it's been by how difficult it is to calculate. But now we can reorder it by how difficult it is to understand the concepts, however hard the calculating. So calculus has traditionally been taught very late. Why is this? Well, it's damn hard doing the calculations. That's the problem. But actually, many of the concepts are amenable to a much younger age group. This was a little example I built for my daughter. And very, very simple. You know, we were talking about what happens when you increase the number of sides of a polygon to a very large number. And of course, it turns into a circle. By the way, she was also very insistent on being able to change the color. Important feature for this demonstration. You can see that this is a very early step into limits and differential calculus and what happens when you take things to an extreme and very small sides and very large number of sides. But that, very simple example, that's a view of the world that we don't usually give people for many, many years after this. And yet that's a really important practical view of the world. So one of the roadblocks we have in moving this agenda forward is exams. In the end, if we test everyone by hand in exams, it's kind of hard to to get the curricula changed to a point where they can use computers during the semesters. And one of the reasons it's so important, so it's very important to get computers in exams. And then we can ask questions, real questions. Questions like, what's the best life insurance policy to get? Real questions that people have in their everyday lives. And you see, this isn't some dumbed-down model here. This is an actual model where we can be asked to optimize what happens. You know, how many years of protection do I need? What does that do to the payments and to the interest rates and so forth? Now, I'm not for 1 minute suggesting it's the only kind of question that should be asked in exams, but I think it's a very important type that right now just gets completely ignored and is critical for people's real understanding. So I believe critical reform we have to do in computer-based math. We've got to make sure that we can move our economies forward and also our societies based on the idea that people can really feel mathematics. This isn't some optional extra. And the country that does this first will, in my view, leapfrog others in achieving a new economy even, an improved economy, an improved outlook. In fact, I even talk about us moving from what we often call now the knowledge economy to what we might call a computational knowledge economy, where high-level math is integral to what everyone does in the way that knowledge currently is. We can engage so many more students with this, and they can have a better time doing it. And let's understand, this is not an incremental sort of change. We're trying to cross a chasm here between school math and the real-world math. And you know, if you walk across a chasm, you end up making it worse than if you didn't start at all. Bigger disaster. Now, what I'm suggesting is that we should leap off. We should increase our velocity so it's high, and we should leap off one side and go the other, of course, having calculated our differential equation very carefully. So I want to see a completely renewed, changed math curriculum built from the ground up based on computers being there. Computers that are now ubiquitous, almost. Calculating machines are everywhere and will be completely everywhere in a small number of years. Now, I'm not even sure if we should brand this subject as math. But what I am sure is it's the mainstream subject of the future. Let's go for it. And while we're about it, let's have a bit of fun for us, for the students, and for Ted here. Thanks.